Hello dear students. In the previous video we already discussed about one very important concept, that is manufacture of ammonia by Haber's process. In this video I am going to discuss the chemical properties of ammonia. Chemical properties of ammonia. In that first point, basic nature. Basic nature of ammonia. Yes, ammonia is one of the Lewis base because of the lone pair of electrons present on nitrogen atoms. You know, formula of ammonia is NH3. Here on the nitrogen there are lone pair of electrons. Due to the presence of this lone pair of electrons, ammonia is one of the Lewis base. Ammonia is one of the base. It accepts a proton to form a ammonium ion. According to Lowry-Bronsted theory, and base is a substance which accepts a proton. When you see this reaction, NH3, here it accepts a proton and it becomes ammonium ion, or I can write like this. Ammonia is one of the base. It accepts a proton to form an ammonium ion. It forms an ammonium ion. Therefore, it is one of the base. Ammonia is one of the base. Next, second point, action with ZnSO4. It's zinc sulfate. What is the action of ammonia with zinc sulfate? Yes. First I write the reaction here. When ZnSO4 is treated with ammonium hydroxide, means in presence of liquid ammonia, it forms the precipitate of zinc hydroxide and ammonium sulfate. H4 twice SO4. Why I write like this? Because you know SO4 its charge is -2 and NH4 plus. While combining this, the charges cross multiplication takes place. Therefore, NH4 this 2 SO4. Yes. Balance this here. NH4 2 make this 2 and another all are okay balanced. When zinc sulfate is treated with ammonium hydroxide in presence of liquid ammonia, the precipitate of zinc hydroxide is formed. This is the precipitate form of zinc hydroxide. It is the action of ammonia with zinc sulfate. Next, third one, Third point, action with copper salts. When copper salts or copper when treated with ammonia, then they forms a complexes having blue color. When copper salts or copper ions treated with ammonia, then they form complexes having blue color. See here, I write some reactions. First you take copper plus 2 means copper ion. When it is treated with ammonia NS3, then it forms the complex. It is like this, Cu NS3 4 2 plus. Yes, here NS3 is 4, therefore make this 4. This is cupr ammonium ion. Cupr ammonium ion. Similarly, if you take an example of salt, CuSO4 means copper sulfate. When it is treated with ammonia, then it forms the complex Cu NS3 4 times SO4. The name of this one is cupr ammonium sulfate. Cupr ammonium sulfate. Yes, here also this one is 4. Yes, according to these reactions, when copper salt or copper ions, when they treated with ammonia, then the complexes which having blue color are formed. Remember this concept, this is very important. This is cuprammonium sulfate. These are some points related to the chemical properties of ammonia. Then, uses of ammonia. Another concept. Uses of ammonia. Yes, ammonia. It is used in laboratory for qualitative and quantitative analysis. Remember, this is very important. Ammonia is one of the very useful reagents in our laboratories. It is used in lab for qualitative and quantitative analysis. Qualitative and quantitative analysis. Next, it is used for the preparation of HNO3. You know what is HNO3? It is nitric acid. In next video, we will see the manufacture of nitric acid. Yes, our ammonia, it is used for the preparation of nitric acid. Next, another one. Liquid ammonia. Liquid ammonia, it is used as a liquid ammonia is used as a refrigerant. Used as a refrigerant. Next, ammonia is used in the manufacture of fertilizers like urea, sulfate, respect to sulfates, etc. It is used in the manufacture of fertilizers. Yes, these are some points which shows the use of ammonia. Yes, students, now we will see the oxides of nitrogen. In this concept, the structure of particular oxide of nitrogen is very important. Therefore, go to the structures of oxides of nitrogen. On the board, I have already written the name of the oxide of nitrogen and its formula. The oxidation state of nitrogen in a particular oxide of nitrogen and the respective structure is written on the board. See here, in that first one is dinitrogen oxide. Dinitrogen oxide, its formula is N2O. N2O, and here oxidation state of nitrogen is +1. Why this is +1? See here, you know oxygen, it is -2. Therefore, when it becomes equal to 0, definitely N2 value is +2. Is it right? N2 value is +2, but only N value is +1. And the structure of dinitrogen oxide is like this. Please refer the diagrams. And another one, nitrogen monoxide, or also called as nitric oxide. Its formula is NO. Here oxidation state -2, therefore it is +2. Oxidation state of nitrogen in nitric oxide is +2, and the structure is written here. And another one, dinitrogen trioxide. Dinitrogen trioxide, in that oxidation state of nitrogen is +3 and the respective structure is like this. Here 2 nitrogen atoms and 3 oxygen atoms are arranged. Nitrogen dioxide, its formula is NO2 and oxidation state of nitrogen in nitrogen dioxide is +4. And here the structure is written. Dinitrogen tetroxide, formula is N2O4 and oxidation state of nitrogen in N2O4 is +4. Dinitrogen pentoxide, N2O3. Yes, oxidation state is +5 and the structure is written here. Yes, in this concept, the structure of particular oxide of nitrogen is very important. For 1 mark question it may be asked. Yes, let's go to the other concept. It is very important for CET purpose. The preparation of these oxides of nitrogen. Preparation of oxides of nitrogen. Preparation of oxides of nitrogen. It is important for CET as well as NEET level examinations. Okay, which one is first here? N2O means dinitrogen oxide. Yes, I write the respective preparation reactions here. When NH4NO3 means ammonium nitrate. When ammonium nitrate is heated, then we get N2O plus H2O. Yes, when ammonium nitrate is heated, then we get N2O. N2O and H2O is the byproduct. Balance this. Here NH4 means 4 and 1 nitrogen, and here also 1 nitrogen, therefore totally 2 nitrogen atoms. What about oxygen atoms? Here 3 oxygen atoms, here 2 and 1, therefore it is balanced. Yes, this is the preparation of our first oxide of nitrogen, that is dinitrogen oxide. Next, another one. Second, which one? Nitric oxide. Yes, see here preparation of nitric oxide. When NaNO2 means sodium nitrite, and it is treated with FeSO4 and H2SO4. Yes, this is one of the big reaction. NaNO2, it is treated with FeSO4 and H2SO4. The reaction between these reactants, we get the product NO, and another byproducts also appear here. It is Fe2SO4 twice plus of NaHSO4 plus of NO, this is our product, plus of H2O. Yes, these are the products formed in a particular reaction. Yes, there are 2 iron atoms, iron present on the right side, means product side, but here only one. Make this 2. When Fe becomes 2, and then SO4 also 2, therefore make this 2, then 2Na balances. Yes, after that it becomes 2, 2. Finally you get 3 moles of H2SO4. You balance, and it is very easy to balance. Yes. Okay, when sodium nitrite is treated with iron sulfate and concentrated sulfuric acid, then we get nitric oxide. This is one of the reactions of nitric oxide. Next, another one. Which one is the third oxide here? N2O3 means dinitrogen trioxide. Yes, take this nitric oxide. When nitric oxide is treated with dinitrogen tetroxide, remember, when nitric oxide is treated with dinitrogen tetroxide, we get the product N2O3. This reaction takes place at 250 degrees Celsius temperature. Yes, but it is not balanced now. Therefore, make this 2. Here also 2. Therefore, 2 into 3, 6 oxygen atoms. Here 2 and here 4. What about nitrogen atoms? 2 into 2, 4. This one 2 and this one 2. Okay, now it is balanced. When nitric oxide is treated with dinitrogen tetroxide, we get the product dinitrogen trioxide. Next, fourth one. Which one is the fourth one? Okay, nitrogen dioxide. Yes, this one is different reaction. When lead nitrate PbNO3 twice is undergo decomposition. At the time we get the products like PbO plus NO2 plus of O2. Balance this. PbNO3 twice. Remember, when 2 moles of lead nitrate do decomposition, at the time we get the products. Number of nitrogen atoms here 2 into 2, 4. Therefore, there is 4. And 2 Pb is also 2 PbO. Next, number of oxygen atoms balanced or not? 3 into 2, 6. 6 into 2, 12. Here 2 plus 4 into 2, 8. 8 plus 2, 10. This one 2, 12. Okay, now it is balanced. Next, another one reaction. N2O4. Preparation of N2O4. Yes. When this is one of the simple reaction. Nitrogen dioxide itself, it changes to N2O4. How you balance this? Make this 2 and O2. 2 moles of NO2 itself changes to N2O4. Next, another one reaction. Formation of N2O5 means dinitrogen pentoxide. Okay, take this reaction. P4O10 plus of HNO3 means P4O10 plus of HNO3 means nitric acid. Then we get the product. Then we get the product PHO3 plus of product N2O5, but it is not balanced. How many nitrogens? Sorry, P4. Therefore, this one is 4 moles of PHO3. 4 moles of PHO3. Then hydrogen becomes 4. Means this is 4. Yes, 4P. What about hydrogen? 4 hydrogen and what about oxygen? 4 into 3, 12. Then make this 2 because 4 nitrogen atoms here. Okay, this reaction shows the formation of particular oxides of nitrogen. Yes, these reactions are very helpful for your CET examination. Students, in the next video, we will discuss another one very important concept, that is nitric acid. About nitric acid, we will discuss in next video. Thank you.